Now, you'll often hear me saying that with complex numbers, well-prepared students will do very well, right? And you'll see it straight away with this part A and part B here. Like a well-prepared student will see these two questions and their eyes should light up really because they're extremely straightforward questions, right? So like this part A, it's nearly an ordinary level question. So that's a root of that. So what's the other root? And like when you see this, the conjugate roots theorem applies. The conjugate roots theorem says that if minus 4 plus 3i is a root of an equation, then minus 4 minus 3i is also a root. So the conjugate of this, so the roots of a complex quadratic are always the conjugate of each other, as long as a, b, and c are real numbers. We'll talk a bit about that now later, but that's 5 marks there now for absolutely nothing. As I said, ordinary level question. And this then is one of your most basic higher level questions, your basic de Moivre's theorem question. You should have this rattled off in under 2 minutes. So what do we want? This de Moivre's theorem. So first off, plot it on a graph. Next we get our modulus, right, which is that distance there, what comes out as root 2. We then get our argument, which is the distance in there, and like without even doing any calculations, you should spot straight away that it's 45 degrees. But if you want to do the calculations, there you go. I did it in radians in this case, but 45 degrees is fine. So we have our polar form, and we just want this now to the power of 8. So we use de Moivre's theorem to get it to the power of 8. And the reason I used radians is like, you've no use for a calculator here really, because it's root 2 to the power of 8, which you couldn't nearly do in your head. But in this case, when you're multiplying out the 8 pi over 4 straight away is 2 pi. Okay, but look, if you want to use degrees, there's no problem there. Type it back into your calculator and it comes out as 16. Okay, so like that's 15 marks, 5 and 10, for doing very little there. And like if you're averaging 15 marks in per question, you're doing quite well. Now, the problem then with complex numbers, and you would have seen it in 2017 as well, is that when you have a very easy first part to it, it probably means there's something bad coming down the line. Okay, now it wasn't as bad as it looks, right? But if you look at part C and part A, they look very similar, right? So minus 4 plus 3 is one root of this equation. In part A, we used the conjugate roots theorem. So why can't we use the conjugate roots theorem here? So it says that that's a root of this funny looking quadratic. What's the other root? So how, like, and a lot of students this year would have just said 1 minus I, as if really you've all this much space to just say 1 minus I. Obviously that's not going to be the case, but why is it not the case? Why does the conjugate roots theorem not work here? Well, if you look at the strict definition of the conjugate's root theorem, all right, so it says for a complex quadratic in the form az squared plus bz plus c, and this is the important part, where a, b, and c are real numbers. Okay, now in part A, it clearly says that a, b, and c are real numbers, so the conjugate roots theorem applies here. Whereas down here, you could see that a is 1, but b and c are clearly not real numbers. B and c are complex numbers, so straight away the conjugate roots theorem doesn't apply here. Okay, so we need to come up with some other approach to this. Now there's actually at least 5 methods that you can use here, all right, for this. Now I think the simplest method is using this formula, and this is a very handy formula to have up your sleeve. So that with any quadratic, it doesn't have to be complex quadratics, that if you write it in this format, the b coefficient is the sum of the roots, and the c coefficient is the product of the roots. So if we take this bit of knowledge, and we know this is one root, we know this is the other root, so if we add up both of these, it should give us the b coefficient in here. All right, so that means that plus that will equal to this in here. And actually, sorry, it's equal to minus this. So just watch out for that minus sign there. That kind of confuses things slightly. And once we have that done, then, right, if we just remove the brackets here, and I highlighted all the real numbers in blue and all the imaginary numbers in green, we can do what's called an identity here. So put all the real numbers equal to the real numbers, like that, and solve that to find what m is, and put the imaginary numbers equal to the imaginary numbers, cancel the i's, all right, they are 1, cancel that I, minus 1, and n comes out as being minus 2. So there you have your other root, 1 minus 2i and 1 plus I. So that's probably the simplest way to do it. Now, some of you are probably thinking, why didn't I use the product of the roots? And sometimes you will have to use this. Sometimes it won't work out as simple as that. But the problem is if you use the product of the roots, sorry, this was all worth 10 marks as well. If you use the product of the roots, it's the same concept, but the identity becomes a bit more complicated and you have to do simultaneous equations. Now you get the same answer, but it's best to just work with this first of all, and if it works out with that, you're good to go. Now, the third method then. Now, a lot of people, as soon as they see quadratics and they think roots of a quadratic, they think, right, minus b formula. And in this case, that actually would work, right? So if you take this and fill in your values into the minus b formula, just watch out. A is equal to 1, b is equal to this coefficient here, minus 2 plus I, and c is equal to this here, 3 minus I. Anything with no z attached to it is c. So now we have to go and sub this into the minus b formula, which is a bit messy looking, right? It'll look like that, but as long as you're careful then. So the minus is there, just watch out for those. Square out the brackets, square the first, square the second, double the first by the second, and multiply all of this out to 1. Doesn't really matter. 4 by 3 is 12, minus 4 by minus I is plus 4i. Now when you simplify that down then, and keep simplifying it down, we actually come down to minus 9, because look, the minus 4i and the plus 4i cancel. Now how do we get the square root of minus 9? Well, that just goes to 3i, right? Because square root of minus 9, that's the fundamental principle of complex numbers. You can split that up into root 9 by root minus 1, and as we know, root minus 1 is I, that's where I comes from. So that's how we go from this to this, and now we must do 2 minus I plus 3i, which is, and 2 minus I minus 3i, that's where we get these two values, and there we get our two answers. So this is the original one we had up here, and this is the other one we had. This is our actual answer here. Okay, so it's same idea, and this was in the official marking scheme. And you got marks really if you did anything with the minus b formula, right? You got 3 marks. And if you got to this line here, right? So if you substituted it all in perfectly and made a mess of it after that, you actually still got 7 marks out of 10, which is generous. And there was actually 2 other possible solutions. I won't go through them in detail now. There was one with, what's happening here now? There was one where you just got the 2 factors, right? So turn them from roots into factors, which is kind of hard to get your head around, and multiplied it all out, and there's a lot more work on it than that, because look, when you get to your final line here, you have to do this whole multiplying above and below with the conjugate. Now, in reality, that's about 6 or 7 more lines here. Okay, so that's easier said than done. And then there's this one where you take your factor and divide it into the original function, which also gives you the same thing, but it's a bit, these two are a bit off the wall really. I don't think many people would have taken that approach, but you still got your 10 marks, and they were actually on the official marking scheme, so I'm guessing somebody must have done them. Okay, so that's again the interesting thing with complex numbers, is that the vast majority would have got A and B right, but this one would have caught a lot of people. Same as 2017, same as 2022, I think was something similar.